All right, so what does histamine do? Histamine actually causes gene transcription on endothelial cells. So the endothelial cells are your blood vessel cells. So the histamine binds to a, 1, 2, 3, receptor. All right, and then binding to the receptor causes gene transcription. And for those of you who don't remember exactly what gene transcription means, is basically it is making a protein, right? Genes are responsible for making proteins. So if you make a protein, if you cause gene transcription, you cause a protein. The exact proteins that the blood vessel cells make in response to histamine binding is a protein called selectin. All right, so this little red protein is going to represent your selectin protein. Random protein, no need to memorize it, but definitely know this is where you look for it if there is a question about it. Okay, so here is another review question. This one's actually optional. You don't have to do it, but there are 7 steps that I have identified in the process of gene transcription. And so number 1 is, of course, the mast cell releasing the histamine. And the last, oh, this should be number 8, sorry. The last step, number 8, is the selectins are on the surface of the protein. So what are the other 6 steps in between that the cell goes through in order for gene transcription? And so this is a chance for you to review all of that. Again, you'll do that officially at the end. Okay, so we're going to focus right here now. So what has happened, because the histamine has bound to the blood vessel cell, the blood vessel cell now makes a new protein called selectin. What the selectin does is it recruits leukocytes to the site. So the leukocytes are moving in your blood. They are white blood cells that travel through your blood. Well, when there are selectins basically act like hands, right? They just grab one of it and say, hey, come right here. Why don't you go ahead and leave through this little opening in the blood vessel and move and come into the skin, because there's a pathogen here that you should kill. And so that is the job of selectins, is to grab the leukocytes so they can leave the blood, right? And then that's what you actually see, that the leukocytes are leaving the blood and going to the site of the injury. The video that you will be watching next shows this very clearly. Okay, so in addition to your leukocytes moving to the injury, your blood contains antibodies. And so because the blood vessel is leaky, there are small openings, antibodies can now leave the blood and move to the site of the injury. And then finally, right, boom, boom, we can see this macrophage, what, wrong direction. This macrophage moves to the injury. So that is what your inflammation response is. The reason my arm got red a minute after I smacked it was because of all the process I just walked through. Underneath my skin right here are leukocytes, antibodies, and macrophages. Here, they're just looking for something to kill. They're not actually going to find anything because there's not an actual pathogen in there. But if there was a pathogen, they're going to attack it, because basically that's all that any of those 3 things do. Leukocytes, they kill pathogens. Let me move my face. They kill pathogens. And basically this chemical is the chemical formula for hydrogen peroxide. They basically release hydrogen peroxide to kill whatever pathogen is there. Next. Antibodies kill pathogens. One thing I will point out, though, is you only have antibodies in your body to pathogens that your body has never seen. And oh, by the way, this fact is going to be really important when we actually really start talking about the SARS-CoV-2 vaccine and future treatments for it that are really going to determine when we can actually stop sheltering in place. So this fact that you only have antibodies to the ones that you've seen is actually going to be really important, because the people who've actually already had the virus and survived it, using their blood is actually a possible treatment that a lot of people are trying to work on right now. All right, and then finally, the macrophage that move, they also kill pathogens, so they just swallow up a pathogen and eat it. But the other thing they do is any other pathogen that dies, they get broken up into little bits, and then the macrophages are basically responsible for engulfing those and destroying them. So they basically act to kind of clean up the area. All right, so that's it. So those are your 3 lines of infection. So you start with your blood, you start with your skin. If your skin's going to prevent most everything from getting out. But just because something gets by your skin doesn't mean you're going to actually get an infection. Neutrophils can kill it, antibodies can kill it, and macrophages can kill it, and especially antibodies, because if you've seen that particular pathogen before, the antibodies will make sure that you kill it and you don't get sick. But if they fail, then you actually get an infection. That's when you actually get sick. So your innate immune response is to help you not get it. And it works almost all the time. It's amazing how effective it is. It doesn't get any credit because you only, of course, care about it when you're sick. But it's the reason you're not sick all the time. All right. So if your innate immune system fails, like I said, you're sick. Well, the symptoms that you're going to have depend on what kind of pathogen you have. If you have a bacteria, do you have a fungus? Do you have a virus? What you're going to feel is going to be depending on which pathogen you have. So the next thing we're going to learn about are the actual pathogens. And because, for obvious reasons, the pathogen we are going to focus primarily on are viruses as a class, and then specifically the SARS-CoV-2. Okay, so now go ahead and you can basically stop this presentation as soon as I actually just stop it now and then go back and review it. But basically here is this slide and then this slide. So part of the assignment that I want you to do is, in addition to summarizing overall what the inflammation response is and then filling out the table of specifics, go ahead and answer these 2 review questions. All right, I hope you understand a little bit more about your immune system. I hope you understand why the next time you get a dodgeball to the face, why your skin is going to turn red. And so I will see you next time.